Well, hey kids, welcome back. By popular demand, we're trying to make some progress on the little Sears 106 back here, otherwise rebranded Gilera. Check that series out if you haven't. But want to try to get a little bit further with the ignition system here. This thing, 67 model, don't know what happened before I got it like 20 years ago. So we're just going to assume that every single part is bad, and it kind of looks that way. So we left off with the flywheel off of there, and we're going through the magneto coils, points, every little thing connected to that, because I don't want to assume anything's good and then chase my tail for a while. So we'll get started with that. Let's commence primary ignition. All right, well, we got this far. If you remember, last time it looked a little different. We got the flywheel off. That was the main focus, and kind of stopped there after we tried to see if we could get some spark. So I wanted to dig in a little deeper and see what was going on. So don't look like it, but I did clean this quite a bit. You can see over on this side where, yeah, it's still pretty nasty. This just needs more cleaning, but we got it to that point. Got it to this point here, cleaning it up. And to do that, we had to take a couple things out of the way. Kind of in order from back to front was this kind of retaining plate that sits down in here. And the reason I had to take that off because the breaker plate and the actual coils mount on a plate that mounts to this. You can get the plate off of there, but this the wiring harness that we'll look at in a second here, it kind of routes through where this notch is, through the notch in this plate, notch in that, and then kind of goes up through here. And there's a grommet that fits against this engine case and through the actual side cover. Let me fit that into the frame here. Yeah, it's notch right there. I got it turned around 180 here. But let's look at some of the parts, and I'll tell you what it took to take that off. All right, like I said, dirty stuff down here. But there was that plate that I was talking about. You see these two little paint marks. I marked them against the notch that you saw in the engine case, just so I had a reference point so I could put this back on in sort of the right position, and also mark this too, so all those marks line up. At least I know that's where it was. Whether it ran like that or not, I don't know. But that's my starting point. I'll tell you, if you've messed with any of these old motorcycles, I mean, especially something little like this, I mean, the screw sizes are like you're working on a carburetor. They're really tiny, and they're usually pretty soft, which is not a good thing when it's 50 years old. Almost 60 years old. This plate right here, I guess I'm going to call it the mounting plate or the retaining plate, I don't know, but it's the one that goes on first. You can see there's a countersink right here. Well, it had these two little machine screws, slotted machine screws. Now, I was able to get these out, definitely get you a nice, sharp screwdriver that fits the width of that all the way across, so you can don't take the chance of stripping it out, because these came out pretty good, and I did clean this up a little bit, but the actual breaker plate that mounted to it, you can see down here this is how it's oriented. There were three kind of pan head screws that goes in there. There's one of them, you can see that. Still, straight blade screwdriver. I think I used the same one. It just worked out. And I had some good kind of snap-on knockoff screwdrivers, really good, sharp, good blades that fit in there really good. The two at the top came out kind of with a little snap. They'd been in there probably since it was built. Those came out pretty easy, but you see this one at the bottom, it was all corroded, and I was like, this is going to be my problem child, and it was. Started to turn it, and I could feel I don't even know if I can find which one it was. Maybe it was this one. We can kind of see there's one that's kind of beat up because it started chewing it up a little bit. I don't know which one it was, but anyway, believe me, it started chewing it up, and I could tell it's probably that one. I could tell, okay, if I keep really hassling this one, I'm gonna strip it out. I'm gonna tear it up to where I can't turn it out, and I didn't want to do that because I didn't want to have to drill it out. So yes, I got some penetrating oil on it, but the main thing that you really need in a case like that is a tool that you have to kind of be a little careful with. It's called an impact driver. It's pretty handy. They're pretty cheap. What it is there's a socket in the end. You put different size bits in there, usually screwdriver size bits. These are pretty good for kind of bigger, like Japanese bikes. It's got the JIS that look like Phillips screws that go into the side of the case. Those are always kind of rounded out and stuck. And those, you get the Phillips bit in there, and I got a good set of bits that put in there. The way it works is there's a cam inside of it, and you can hear it kind of turn left or right, and because it'll work forwards or backwards depending on you got right or left hand threads that you're working on or which way you want to turn it. And you basically push it up against the screw and turn it up to the direction you want to go, and then you tap the end of this. And I said tap. I didn't say pound, because you're not trying to kill Count Dracula with this, especially on this thing that's all aluminum with these little screws. I was pretty nervous to use this because I'm like, well, I'm going to strip it out with hand force, but maybe if I tap it on there once, it'll break it loose, and it did. But I mean, I took a pretty small ball peen hammer and just kind of maybe pulled it out here and went smack and hit it, and that cam lets it twist a little bit and pops it out. So there you go, impact driver, and it knocked it loose, it pulled it out. So the tool saved the day, but it's definitely something not for the faint of heart, I guess. And a lot of people don't get the cam gauge first too. They'll just stick it on there and smack it and it won't do anything. You need to get it up like that. You can hear it, like I'm loosening, for right hand threads, that would be the right way to loosen, and there's the other way. So you got to get that set first, and then you strike the end of it or tap the end of it. Just tap it in, and it should come loose. I mean, repeated pounding on it probably is not advised. If it ain't coming out, it ain't going to come out, and you don't want to break something or make it worse. But back to the issue at hand. So we got all this out here, and I was like, this doesn't look too bad. And then I started noticing our breaker points here. This was completely frozen. It would not move at all. So I'm like, that's probably at least part of the reason when we don't have any spark. I was expecting to see this being a lot more kind of a corroded state back here, which it ain't pretty. You can see the back of the condenser right here. Looks pretty nasty. So we may have other issues, but the main thing I wanted to do is get this out of here, make sure these wires aren't broken, get a continuity tester on it, because even the insulation is starting to come off of them. So we may need to do a repair there, but at least see, from the ends of each one to where they land on this breaker plate here, is it actually connected? Because it might not be, it's been a long time. And then try to clean these points up. I got them to where they will actually move and spring back. I mean, because, it only moves like, I have to look at it again. It's like 16 to 20 thousandths or 18 to 22 or something like that. There's a range in there, but it's these points are pretty nasty, so they may not come back, may not be able to clean them up enough. And we'll go over the kind of the way you should do that, and the way that a lot of people do that causes them more problems here in a second with a tool called a points file that you may or may not be able to still get. But we're going to give a shot with that. So we got two things to do. One is, I want to test all that wiring while it's out, just so I can hold it in my hand here and check it out and see, is it actually connected? Step one, and then we're going to clean the points up, and we'll put it all back together and hook things up and try to see, at least, is it, when these magnets on the flywheel here clean this up a little better too. When they spin past the coils, do we have anything that happens? Because before we got nothing. So, but it could have very well been because those points were stuck. That's kind of what I'm hoping. But we're gonna find out. All right, we mentioned cleaning the points here. There's, I guess, a school of thought that you can get something abrasive in here and swing away on this, and yeah, that could work, I suppose. But the problem is, if you use something like your wife or girlfriend's or your own nail file, or a piece of sandpaper, those things do what they're supposed to do, but they don't stay clean, and they will leave a deposit on here. So even though you think, okay, I'm getting this flat, that's great, but the more important thing is to get it to where it makes a good contact, because it is, it's an electrical component. It's breaking a circuit. Hence the breaker points. They make a special tool for that, which I used to believe it was called a points file. That's what I always called it if you asked for one. But evidently these days, since points are kind of moving out of motor vehicles, at least, it's called an ignition point file or an ignition file. Now, I've got a couple of these in my toolboxes, and I can't find them. So I actually had to go buy this one. It's not super expensive. It was $4. It's a double cut file, which is kind of unusual for files. And you should only, even though I think if you flip it over, it says, oh, you can do all kinds of stuff with it. I mean, this should be like a dedicated tool. Don't use it on anything else. I have no idea why it shows a spark plug on here, but don't use it on anything else but points. Keep it clean. Don't let it touch anything else. It's super fine, super smooth. Yeah, I know I'm getting into a realm here where I'm probably going to get some angry comments that, you can use 400 grit sandpaper and rock out and get it done. But this is the right way to do it. Do what works for you, but this is the right way. Get you one of these. The funny thing is, the reason why I have a couple that I can't find, not because I can't find them, but the reason why I have a couple is because they used to just give these away when you go to the auto parts store. That's how old I am. When the era of points was still kind of a thing, even though it was going out when I was a little kid. But there were plenty of cars that had points on them, and they just give you one. It was just a tchotchke at the parts counter. Especially like a Napa or a CarQuest or Speedway Auto Parts or something like that. Hey, you want a points file? Here you go. So we're gonna pop this out of the package, and we're gonna just kind of lightly dress these points to try to flatten them out, because they weren't fused together. The pivot was bad, but they're pretty nasty, and without a microscope, you're probably never going to be able to see what I see. But you need to clean them up to where it's a flat surface on each side, or flat-ish surface, to where they're making good contact across those two discs. It does seem like old technology, but they still use points in like heavy-duty electrical equipment, like a motor contactor or something like that. Or at least, as far as I know, they do. I mean, I've worked in that trade for a short while, and they still had them, and they still sell these things as such. However, get you one. It's cheap. If you got something with points in it, that's the right tool to use. So we'll get this out of the package and move forward. All right, this is hard to do and hard to see. I kind of got got it in between the two contacts of the breaker point set, and I'm basically letting the return spring on the points kind of provide the tension here. I'm looking at this, and it looks like there's like no surface left, but we're going to try to clean it up anyway. So as you can see, I'm just kind of trying to work it back and forth and keeping it from hopping out of there, which isn't the easiest thing to do. this is how I got it in there. I got it kind of stabbed straight in, but I just pulled them open and slid the file in there. You know, I'm not putting any pressure on it at all. It's the spring that's putting pressure on it, but I'm trying to clean it up a little bit. And just like, you know, doing body work or anything, I guess when you're using a file or something like that, you let the tool do the work, and you know, you kind of move it till the resistance changes. So that's what I'm sort of feeling for, is when it gets to the point to where I don't feel it removing material. I figure, well, it's relatively flat, or at least it's not the whole high spots off of there. But you know, I'm just really just wiggling it back and forth. As you can see, my fingers moving here. These are bad. That's, you know, normally cleaning these up would just be, you know, a couple swipes and you're done. You know, unless there's something freaky going on, like the condenser was bad, which leaves like a deposit on one or the other, makes like a stalactite, I guess, best way to describe it. But I can't tell if I'm making progress on this thing or not. It feels like I am, but I think anything's better than what we had, because it was stuck so bad. And I'm wondering, I always had this bike stored inside, but I'm wondering if maybe it was outside for a while, and that's why we got this condition that we're dealing with. But we'll clean it up. I mean, if they're bad, they're bad, and I got to replace them, or you know, if I can find some. I think maybe they're out there, but yeah, see, it just jumped out of there. But we might be done. Like I say, it's really hard to see in there. But obviously, since we're, you know, resurfacing them, we're gonna have to change them. But I don't want to grind it down so far where there's nothing left. I mean, you can kind of see now. You kind of see the different colors in there. You know, it's steel back here, and then you kind of see the actual contact point material itself that's in there. I think I may stop with this right here. I mean, they're opening and closing, and you know, maybe I'll dust that off of there. I've heard of people using, you know, some paper or something in there to wipe it after you've used this thing. Use the points file, but you know, there's detractors of that too, because, you know, depending on what tooth of paper you use, you may leave some deposits in there, and the whole thing is to make a good electrical connection. But you know, since this was frozen, nothing was happening. So if we get something out of this, I'm going to be happy and call that a win. So I think this stage of what we're doing is done. Like I told you a few minutes ago, I want to test these wires out, and they're stiff as a board. So if they got breaks in them to where there's no continuity between the ends of these leads here and where they connect, you know, that's a big problem, and it's not going to do anything without that. You know, and I want to hook it up, hook the continuity tester up, and wiggle these wires around, because they may, you know, work in one position and then, you know, get a little wiggle and they stop. So we'll figure that out next. All right. Well, good news. My continuity tests for all three wires, it passed. I'll show you what I did. I mean, this is the easier one to get here. This is the black wire going to the points. Basically, you can hear that beep in the background. Pretty basic. It's just saying, yeah, there's a connection between these two. What I wanted to find out is, beyond it working in one position, since these wires are really dried out and brittle, I wanted to see if it, you know, moved around, if it would cause a short. Well, you hear it kind of intermittently there, but that's because I'm moving. But you know, I moved the wire around, and I lost contact there, because the end of this wire is just trash. I should probably clean it, but we'll hook it back up again. I'll show you what I was doing. My good meter, the batteries are dead, so I had to use an old Radio Shack one. If you ever heard of Radio Shack, it was in the trash at work. But yeah, just wanted to make sure if it vibrated, if it still would complete the circuit, and they all did. Yeah, this is so corroded, and the leads on this thing are really tiny. As you can see there, my other one, my kind of A unit there, which is a snap-on, one of the few deluxe tools that I got. It has you can take the leads apart and put alligator clips on them, and it's a whole lot easier to do this kind of testing now, where you have to grow a third hand to hold it on and move it around. So I'm stabbing these in, and unfortunately I can't use my snap-on tool leads on this one. They don't fit, but it'd be nice. But anyway, that's what I did. So all three wires, the red, the black, and the white, they work. Now, say this is, I mean, look at this wire. I mean, you know how wire would behave. It's like a brake line or something. It's so dried out and stiff. What I'll probably do is, when I put this back together, and we're going to see if it works here in a little bit. I'm going to put this back together as it comes out of the engine case that I showed you earlier. I'll probably cut it right there and replace it with new wire that has some flex to it. Because I just don't want to desolder all this stuff and run it back through there, because I'm not the best at that. I got some friends that are. Maybe I can sucker them into helping me with that, but I'm probably going to leave that alone until it causes a problem. But we're going to see if these coils actually operate, which we could test them, but I'm not going to. And if those horrible points actually work here in just a few. All right, we started putting this back together here. You can see I got the kind of intermediate plate, or whatever the heck I'm going to call it, in there. I did put, a little bit of very little bit of anti-seize on these screws. Those weren't really tough to get out. Definitely get you a sharp screwdriver. I like these short ones for jobs like this, because it's kind of torque limiting there. Because you're going the anti-seize, you're going steel screws into aluminum, and galvanic corrosion and all that bad stuff, which is what we had on the bottom screw that we discussed earlier. So I'm going to put anti-seize on those as well, on this breaker plate, coil plate. We're going to call it magneto coil plate. The big thing, I guess, is that I wanted you to see that the wiring kind of like threads through that. That's why I had to take this back plate off, intermediate plate off, because I wanted to get the breaker plate completely out, and it's kind of caught in there. And obviously this little grommet goes up against the side of the engine case, and there's a cutout in the side cover. But we'll go ahead and bolt this down, and you see my paint marks a little bit clearer here where I had it. That's where it was, so at least we can put it back where it was. Whether that is going to be in time after we've goofed with the points or not, or whether it was in time before ignition timing, I don't know. But at least we don't introduce a new variable into it that maybe it was right and we made it wrong. So we'll see. Okay, that's what it looks like with the points plate installed. I actually took the kind of chewed up screw that was on the bottom here that I had trouble getting out. I put it up into this position, swapped them. They're all the same size, but I put it up here in case we have the same issue. I didn't want to, later on, I didn't want to keep chewing, the screw up worse. So I kind of put, the marginal, well, the damaged one, I guess, into a more accessible spot, which that one came out easy when I moved it before, but you can kind of see my paint marks up here. So I got it back where it was when I took it apart. And the next step is a little more complicated. We're going to put the actual, magneto flywheel back on. So we'll clean that up a little bit and get it on there, and I'll show you what I think we need to do to make it easy to put on. So that's next. I do have to back up here a little bit because kind of get a situation that I want to make sure I get it done right. There's a Woodruff key. If you don't know what that is, it's basically just a tiny little piece of steel, tiny enough that probably going to be hard for you to see it. Yeah, especially in between my gloved fingers. Let me get a better look at it. But kind of looks like a little part of a circle, little wedge, I guess. It's kind of flat front to back, but anyway, what it does is it kind of keeps whatever you're bolting onto a shaft from turning. There's a little, kind of arc slot in there too that this fits in. You can see that slot right there. This is little. I mean, it's like 3 millimeters wide. Be careful, don't lose that. This is pretty beat up, but it's not shifted or slipped enough to where it's going to cause a timing issue, but it really needs to be on there because that's what keeps it in time, basically, because there's timing marks on the magneto here. If you can see, it's got TDC marked, and I think that's the timing mark, and then the advanced mark, those other two ones on there. Pretty sure it's what it is. Have to look at the manual, but regardless, you want it indexed properly. Well, the trick here is to get this on there with the points cam that is kind of an eccentric around this shaft. That's what that springs on there is, the centrifugal advance. But to slide this over, basically pushing the points open and not disturbing the key, getting it all locked in, lined up. It's you can't get behind it. When you're putting it on in the front here, you're going onto that groove in there onto the key. I mean, you can't hold anything. You just gotta line it up, push it in. So what I'm going to do here, which I believe is going to work, I'm going to clean this up the best I can. The key and the crankshaft snout here, and the shaft and the balancer. Get the paper towels, Q-tips, whatever it takes, and some brake clean it up, dry it up, and then we'll put a little bit of super glue on there. Now, I know that's not gonna, hold it, lock it down, but it'll hold it long enough that it won't move when I put it on there. There's other ways I guess I could do that. You probably put some grease on there and it might hold it long enough to, keep it from shoving it out of the way. But basically, this thing curves, away from us like that. So when you're pushing it on, it's trying to scoot it right out of there. And when I was playing around with it earlier, pushed it out of the way and then ended up on one of the flywheel magnets. So at least I didn't lose it, but I'm just like, yeah, I want to try to, restrict its movement here a little bit. So we're going to give that a shot. So gotta let the glue dry. But in the meantime, what I did, because we're going to have to set the points here, is, this is probably impossible to see, but around that is an eccentric. What I mean is, like a circle that doesn't share the same center, and that kind of orbits when the motor's turning and pushes the points open and closed, or pushes them open and the spring closes them. I marked on the outside of this the high spot for that cam. Now, I mean, it's kind of irrelevant because this is the adjustment window, but, I want to at least know, all right, I'm getting in the zone here, because you can't see it, can't see where that eccentric's at when this is facing us this way. But dwell affects timing, and we want to get it back to get the right point gapped so it has a correct dwell, and give us the best shot of running properly if all this other stuff is electrically sound. So it starts getting pretty complicated, but we'll get there. It's like I can't remember who said this, but it's like slow is smooth and smooth is fast. I mean, that's kind of the way you do it. You don't have to, if you do it right, the first time, then you don't have to go back and do it again. And this stuff is, like I said, tiny stuff like working on a carburetor or a pocket watch or something. Take your time, go slow. It's not a race. We're not getting paid to do this. If we were, maybe we would have a different goal here, but I'm taking it easy because parts for this are too hard to get. So we'll glue that in, put this back together, and keep moving. Well, hey, that actually worked. Did we have any doubt? You can kind of see behind the torque wrench here, got my little eye bolt flywheel holder from, let's see, make sure it doesn't fall. From the last couple of videos there, I actually put a nut on it because you don't want this sticking in too far and hitting those coils in the magneto. That's how we got it off last time. And if you remember, this is left-hand thread, so it's backwards from what we're used to. It's not righty-tighty, lefty-loosey. It's lefty-tighty, righty-loosey. So don't screw that up, especially if you're trying to get this off of there. And probably need some kind of flywheel puller that we went over in the previous episodes if you haven't seen those yet. But anyway, the key stayed in place, got it on there. I was able, when I got it started, probably hard to see with the camera position here, but I pushed the, well, maybe you can see it, push the arm for the breaker points kind of out of the way to kind of guide it on before I kind of, massaged it in place with the, rubber mallet. I mean, this is aluminum, so I wouldn't be, kabonging this with John Henry hammer if you got one. But they did make a specialty tool. If you've got a factory service manual for this, kind of looks like a plate that fits on there, and works kind of the same way. It looks like it might have grabbed onto the rib in this case here, but it just keeps it from turning. And otherwise you got to do something dumb like grab onto it with channel locks and tear it all up. So this works pretty good. Just you can definitely improve upon my lazy 30-second design here, which is just an eye bolt with a bend in it and then a little stop to keep it from going any deeper. I mean, you could bend a nice little offset in here. If you don't like pulling on the shifter shaft, you could hook it into this or something. I mean, it's really just to kind of keep it from moving. That's all that it does. So you can loosen and tighten it, which we're going to do here right now. So like I said, it's lefty tighty and it's 40 foot-pounds. So a little bit more, and I knocked it loose. That's okay. Like I said, I don't have a absolute ideal angle for holding this, so I knocked it off when I was tightening it. But we're probably getting close. That's the reason that it jumped off of there. So we'll keep doing that. This is how you know it's real, folks. There you go. Did you hear that? Now we're done. A lot of people get tempted to, click it 2 or 3 times, but you're just continually stressing the fastener. So don't do that. That part is done. Now it's on here, so we're relying on getting the points adjusted next, and we'll hook the wiring up in a kind of a, I guess what you'd say, like diagnostics test mode, and we're gonna run it around here with the actual transmission output shaft, which I'll tell you why I'm doing that in a minute, and it hopefully makes sense. Be right back. Okay, with this camera equipment, it's probably going to be a struggle to see what I'm talking about here, but pause it, zoom in, whatever you need to do. I think you can figure it out. If you got one, I think you will definitely know what I'm talking about, but I want you to be able to see what I'm doing here the best that I can. So we're getting ready to adjust the points, and I'm going to try to use screwdriver kind of as a pointer in here. That right there, that's the breaker points. You can see that we filed earlier. This right here is the wire, the electrical connection to it. This biggest screw, right kind of in the middle of the set here, that's the kind of the lock screw for the adjustment. And then what is going to be kind of hard to see, and there's just no way to really point it out because it's so tiny, is why I have this little screwdriver right behind there. If you can see the spring coming around here, that's that curved piece of metal. If you can see that slot, I'm pointing straight to it. It's kind of 12 o'clock, I guess, from the point of this. That's the adjuster. There's a eccentric on there, and when you put the this little small screw in there and you turn it back and forth, and let me see if I can do it. I may have to move the camera here because I've got it really close. When you put it on the adjuster, a little bit more. And you might have to kind of push your spring out of the way here to get her on the head of that screw, but that's okay. And if you can see up here at the top, well, you probably can't. Hang on, move it again. You can see the points here. You see those moving? I'm going to turn that screw. It's moving those points back and forth. I don't know if you can see it rocking. I can see it rocking, so I'm hoping you can. That's how you set the gap. When I started in here, it was way off. I mean, it was humongous because the gap from the manual between these two contacts here, the points, contact points, is supposed to be 14 to 16 thousandths of an inch. It was way out there. It was at least double. I mean, I've closed it up here just because always making sure things were loose. So here's the procedure. What you do is you open it up enough that you can get your feeler gauge in there, which I had to dig through my toolbox to find a feeler gauge that was thin enough because there's really not a whole lot of room in there. But these look horrible, but they're clean, I assure you. They're just old and beat up because I've probably had them since I was 15. But I'll be able to stab these in here. So if you got a set of feeler gauges, some of them are pretty wide, so you need something pretty small. Because what we're gonna do, I'm gonna open it up, I'm gonna stab it in here, and then back on this screw that I showed you a minute ago, I'm gonna close it. The one that was down here behind the spring that we're not gonna be able to see anymore because it's in shadows. We're gonna turn it to where it open it up first, and then we're gonna close it onto the feeler gauge until we just get a light drag on there. And what's a light drag? Well, I don't know if you can explain it, without actually feeling it. I mean, it's definitely, if you pull the feeler gauge out and you hear a snap, okay, that's not a light drag. You are holding it open with the feeler gauge, and if it just flops around and you can rotate it, you got no drag. So just kind of experiment with it, go back and forth. This shouldn't, if it's clean, for sure, these should not damage the points. You can see probably over the years they have been a little bit beat up, but this is definitely clean. I'm not going to transfer any schmutz onto this, but put it in there to where it just lightly moving them. Well, not moving them, but to where you can feel the tiniest bit of resistance on there. And what I mean is, it's not pushing them open, and there's no air gap in there. So once you get to that point, you should be in the range that's required for this, because that's why I picked 15, because it's 14 to 16, because I figured, the tool's worn, the points are worn, let's kind of shoot down the middle. So that's what you do. It's just too difficult to film this. Definitely, if you got any questions about what I'm talking about, put them in the comments. I'll try to explain it a little bit better. But this is old hat for anybody that's adjusted points before. I would say, this is probably one of the harder setups to adjust, because you're doing it at a right angle, and it's definitely, you're stabbing in tools blind in some cases, but it's not impossible. Take your time, get it right. If you got to do it more than once, so what? Just keep trying. But it worked out that turning it around to this adjustment slop, this big kind of kidney bean shape here, that is, as you would imagine, that is pretty close to the high spot of the points anyway. But I just wanted to make sure that something hadn't, because for all I know, this stuff is damaged, and it's way off, but it's right on. So we'll get those adjusted, and we'll move on to the next step. Well, here we go. I told you I was going to make like a diagnostic type setup for this. That's kind of churching it up. Probably it's pretty rigged here, but what I wanted to would do is see if the magneto was actually working, the points were working. There's a lot of other stuff we could have tested, and I didn't. So I'm jumping ahead. There's some troubleshooting if you had no spark. You test the coils, you test, whatever, the effectiveness of the magnets. I mean, it gets so deep, but I'm just like, hey, this probably ran and somebody just stopped riding it. So let's go ahead. Anyway, you guys all know this. You've been watching the channel. You've been watching the series on this. What we did is there's 3 wires coming out here. And the sheathing all came off of here, but what looks like red is actually red. What looks like red with white on it is supposed to be gray, and what looks like black is supposed to be green. Now, green is what goes to the lighting on the bike. And one of the things that they warn you about is that if the taillights burn out, because it's normally closed, it's grounded, if the taillights burn out, you hit the brake lights and the brake dies, or the engine dies, that means that the bulbs burn out, which is crazy. But if you look at how it's wired, it makes sense. The funny thing is there's 2 coils in here, as you saw when we were working on it. The 2 coils, one is ignition system and lighting, which the aforementioned, brake light problem. And the other one is, I think, just dedicated to the horn. That's the red wire. So it doesn't matter if it works or not, which I assume that it works. I don't know, because we didn't hook it up. It's just hanging out in the breeze here. What we did hook up was the brake light. As you can see, the black/green wire, it's grounded right here. So it says, okay, I'm working or I'm not being used, whatever the case may be. And then you can see the alligator clip going up and over to the test light, which is hooked to the red wire, pretending to be the grayer wire. I don't know why this isn't in focus, but that's the 3rd wire on there. The actual red one that goes to the horn is not hooked up at all. So we more or less said, brake light's working. Let's see if there's a signal going to the primary side of the coil. And if you don't understand how that works, there's plenty of information out there. But basically, there's a low voltage side and a high voltage side. And the low voltage side comes to the points on time with those breaker points to the coil. And when those breaker points let the ground loose, then it jumps to where the next ground it can get, path least resistance, that goes to the high voltage side, which is the spark plug. So yes, maybe I'm not explaining that correctly or in the best way, but that's really how it works. I mean, there's kind of two parts to an ignition coil. I'm not even going to bother testing that. All I want to see is, can we get a signal out of the magneto to where it will trigger the coil, because the coil may be bad and I don't want to test it on that end. So here we go. Let's see what happens. I'm going to push the kicker with my hand here. You can see that test light. That's going to say, are we getting a signal or not? Oh yeah. I'm going to call that a win. So that's called the primary side of the coil. It works. So theoretically, if we had a working coil and the ignition timing was sort of right, which it probably is. I didn't change it. As you saw, I set the made the painted marks, and I set the gap, so it should be back to where it was probably when it ran last. Carburetor, I'm sure that's wrecked, but we get that going, this thing might hit. So next chapter, we're going to mess with the coil, see if we can get actual spark to the plug, and maybe juice this thing up and hear it bark back to life. But that's more to come, and we'll get there eventually on Smith Motor Works. Thanks for watching.
Well, hey, what'd you think about that? Success. I'm happy. Hope you're happy too. Maybe you pick something up to work on your own project there. These things are so basic, but there's enough that's been setting on this, enough times passed that, as you saw, like everything's corroded, everything's stuck. And, it probably still needs a little bit more cleaning and tweaking to make it tip top, but we'll get there, and it's done more than it has in, say, 20 years since I got it. One thing I didn't really touch on here that I wanted to show you is this little special screwdriver. It was my granddad's. It's really not a screwdriver. It's more of a screw holder. If I can see what the name of this thing is here. I cannot. It's worn out, but I will tell you, if you can find one like this, it's kind of like two screwdrivers together. They kind of wedge in and out. Probably can't see that, but that's how I was holding those screws when I was putting them straight in. Otherwise, you're either going to have to balance them on the end of the screw, which they're going to fall off, or you magnetize it, and that works if nothing else is magnetic around there. But this was, so when I magnetize the screwdriver, I try to stick it in there and it jumps to something else because now everything's magnetized. But what's happening is, which you can't see, two of those blades and they're sliding together, they're getting thicker. And as you slide it together, pushing a little collar on there, it wedges itself into the slot in the screw and it holds it. It's just enough to get it started and then stop. Because if you keep twisting on it, you'll tear it up. So just get the thread started, pull that collar back, it pulls those apart, lets it come loose, then you can tighten it with a regular screwdriver. Pretty good. I'll try to put this in the comments what it is, because I'm gonna have to get a magnifying glass. These just ain't enough to see these little letters on here, but I assume something like this is still around. He probably bought it in the 50s or something, but they got to make something like this. If not, maybe you can make something of your own. Who knows? Dare to be different. Thanks for watching. Please like, subscribe, share, comment. Comments how I got to know that you guys want to see another video on this motorcycle. I do listen and I try to make you guys happy, but we're always going to be working on something, and we'll see you next time on Smith Motor Works. Bye-bye.